This first code cell is all about getting our data ready for analysis. We start by importing three essential Python libraries: pandas, Seaborn, and matplotlib.pyplot. Pandas is a powerful tool for working with structured data like tables. Seaborn and matplotlib are used for creating visualizations. We then load the famous iris dataset, which is built into the Seaborn library, into a pandas data frame called iris.df. A data frame is essentially a table-like structure where each column represents a variable and each row represents an observation. Finally, display-based iris.def head shows us the first 5 rows of the data frame. This is a crucial initial step to get a quick look at the data's structure and content, confirming that the data has been loaded correctly and understanding the types of values present in the columns. It helps us catch potential issues early on. In this next cell, we dive into the data to understand its characteristics through exploratory data analysis, or EDA. First, iris.df info provides a concise summary of the data frame, including the column names, the number of non-null values in each column, and their data types. This helps us identify if there are any missing values or if columns have unexpected data types. Next, iris_df dot is null.sum specifically calculates the number of missing values in each column, giving us a clear picture of data completeness. Iris_df dot describe generates descriptive statistics for the numerical columns, such as mean, median, standard deviation, minimum, and maximum values. These statistics provide insights into the central tendency, spread, and range of the data. Lastly, iris_df species dot value counts the occurrences of each unique value in the species column. This is particularly useful for categorical variables to understand the distribution of different categories. These EDA steps are fundamental for gaining initial insights into the dataset, identifying potential issues, and informing subsequent analysis or modeling. This next code cell focuses on data visualization using a pair plot, which is a powerful tool for understanding relationships between multiple variables simultaneously. We use seaborn.pairplot iris_df and hue is equal to species to create this plot. A pair plot generates a grid of scatter plots where each numerical feature is plotted against every other numerical feature. The hue is equal to species argument tells Seaborn to color the data points based on the species column. This allows us to visually differentiate between the different iris species and observe how their measurements vary. The diagonal of the pair plot shows the distribution of each individual feature, often as a histogram or kernel density estimate. Pair plots are excellent for quickly spotting correlations between variables, identifying clusters of data points, and understanding how different groups, in this case, species, are separated based on their features. It's a great way to uncover patterns and relationships that might not be obvious from just looking at summary statistics. In this final code cell for visualization, we further explore the data's distribution using box plots. Box plots are a standardized way to display the distribution of data based on a 5-number summary: minimum, first quartile, Q1, median, third quartile, Q3, and maximum. They also show potential outliers. We create separate box plots for each numerical feature: sepal_length, sepal_width, petal_length, and petal_width, and group them by the species column using seaborn.boxplot. This allows us to compare the distribution of each feature across the 3 different iris species. By examining the box plots, we can visually compare the medians, spread, interquartile range, and variability of each feature for each species. This helps us understand how the different species vary in terms of their physical measurements and whether certain features are better discriminators between species than others. Box plots are particularly useful for comparing distributions across different categories and identifying differences in central tendency and spread. This concludes the basic steps of data analytics using pandas, including data loading, exploratory data analysis, and visualization. You can now proceed with more advanced analysis or modeling based on your specific goals and the insights gained from these initial steps.